Welcome to the demonstration of the HIBI SDK with its two modules EverKey for decentralized and opaque backup and recovery of secrets, and EverID for deriving a verifiable credential based on the eIDAS framework. In this demonstration, we show the SDK in a custom Electron.js user interface. However, it can be deployed into any Android mobile application as it is written in Java and Kotlin. The SDK is meant to be deployed directly on the client devices and is not run over a cloud service. By using the eID, we overcame the challenge to get trusted identity attributes and a unique value for the credential attributes and the backup respectively. Store.js solves the issue that the user does not have to store the data on its own, nor that the data can be accessed by anyone else. And to the eIDAS to SSI bridge gives the credential credibility for third parties to verify the credential. Here you can see the graphical user interface of EverKey. On the right side, you can see the OSWES app to extract the data from the ID and the PersisSim application, which simulates an eID scanning and the eID authentication. To begin with HIBI, we need to authenticate with our eID. For simplicity, we only authenticate once. However, when deployed on a client device, the user needs to authenticate every time the HIBI SDK is used. To do this, we click on the Authenticate button. We can see in the background that the OSWES app requests the PIN of our simulated ID card. We choose a simple PIN for testing purposes, which is 1, 2, 3, 4, 5, 6 for the testing eID cards. The authentication takes a few seconds, so we will just wait. Now we can see that we were given the option to backup and recover secrets respectively. As well, we have the option to use the EverID service for receiving verifiable credentials. Let's start with the backup process. Here we are now able to enter our secret. We need to give it an identifier so that we know which secret we're storing. So let's say that we want to store our Ethereum mnemonic. To enter, we need to enter the secret respectively that we want to store. So I will just enter some random words, and now the secret is stored. The secret is being shared by using Shamir secret sharing and sent to the decentralized storage grid by Storj. A directory matched with the restricted identifier that we entered is created on Storj, or created a new directory if it's the same directory is not available. Okay, now let's try to recover the secret that we just stored. So we'll just enter the identifier that we stored earlier, which is mnemonic, and this is the mnemonic phrase that I stored just a second ago. As you can see, this is the secret, and this will be returned to the consuming services of the SDK. Let's continue with our EverID module. From our previous authentication, you can see here that we extracted the name and the surname of the user. This can be adjusted to the user's respective needs with other attributes which are supported by eIDAS. To derive the verifiable credential with these attributes right here, we just click on the Get VC button. As you can see, we now have received a verifiable credential that contains information about the issuer, which is us, EverKey ID, and the attributes of the credential subject itself, which is the name and the surname of the card attributes. Along these attributes, we have the proofs to prove the validity of these credentials. Along with this, we also created an address based on the restricted identifier, which serves as the user's ID. This is already a well-formed credential according to the standard from W3C, which a consumer can import into their SSI wallet. In order to provide a higher level of trust in the certificates, we sign this credential with an eIDAS compliant signature by using the EverID bridge, which is the eIDAS to SSI bridge, and the EverID's service. This allows the third party to verify the issuer of the credential and see its legal identity. So our verifiable credential is verified. To sum up the HIBI project, the user is now able to perform a decentralized backup and recovery of her secrets without the need to remember anything as long as she has physical access to her ID. Further, the user can now identify herself in a decentralized and secure manner towards any consuming service in the on-chain ecosystem. Thank you for watching.